One of the more persistent claims in NMN marketing is that the compound demonstrates superior brain bioavailability compared to older NED plus precursors, and that this translates into better neuroprotection, cognitive enhancement, and protection against age-related neurological decline. The claim has intuitive appeal. The brain is metabolically demanding. NED plus is essential for neuronal function and DNA repair, and getting ND plus precursors across the blood-brain barrier is genuinely important. But the evidence behind the claim is considerably messier than the marketing presentation suggests. The blood-brain barrier is a selectively permeable structure that tightly regulates what enters the central nervous system. Not all molecules cross it with equal ease. Large, hydrophilic molecules generally cross less well than small ones. NMN is a relatively large molecule by metabolic standards. Some research suggests that NMN undergoes significant degradation before it reaches the brain, that it's converted to nicotinamide in peripheral tissues before crossing the blood-brain barrier, meaning the molecule that arrives at the brain may be nicotinamide rather than NMN itself. If that's accurate, the superior brain bioavailability claim loses most of its foundation. Nicotinamide, the form of niacin that doesn't produce a flush, actually crosses the blood-brain barrier efficiently and readily. It's a small molecule that penetrates central nervous system tissue without difficulty. The brain expresses the enzymes necessary to convert nicotinamide into NED plus locally, and there's a meaningful body of research demonstrating that nicotinamide supplementation produces measurable increases in brain NAD+ levels. This is less commercially exciting than claiming NMN's brain penetration advantages, but it's better supported by the available evidence. Niacin's contribution to brain health operates through an additional mechanism beyond NAD+ elevation. The flush it produces includes increased cerebral blood flow, the vasodilatory effect that characterizes GPR109A activation doesn't stop at the neck. For individuals with age-related reductions in cerebral perfusion, this vascular component may represent a meaningful neuroprotective effect that pure NAD+ precursors don't replicate. There are legitimate uncertainties here. Some in vitro and animal data does suggest tissue-specific differences in how NMN is handled compared to nicotinamide or niacin, and some of those differences may favor NMN in certain cellular contexts. The research is still maturing. What can be said with confidence is that the NMN crosses the blood-brain barrier better narrative is not a settled finding. It's an interpretation of incomplete data that happens to support a commercially convenient conclusion. The practical guidance that emerges from an honest reading of this evidence is to be skeptical of brain health marketing for any ND+ precursor until the human neuroimaging and biomarker data matures. In the meantime, nicotinamide as a direct supplement is an evidence-supported, inexpensive route to brain NAD+ elevation. It deserves more credit in this discussion than it currently receives.